Hi everyone, today we're going to talk about product rule and quotient rule. So these are the formulas that are quite important in this chapter, and in fact it's the most important one in this chapter for differentiation. It will be used in maybe this chapter or the questions in another chapter. Okay, so together with chain rule that you will learn later on, so this forms the most important thing in differentiation. Okay, so we will talk about product rule and quotient rule, the formula. So it's a revision of the formula because we have done it in the previous lesson. Okay, so let y to be equal to u dot v, u times v. Okay, so u and v, they are both a function of x, of course. Okay, so u is something like 5x plus 1, v is something like 1 minus 2x squared. Okay, then you multiply them. Then you wonder, how do you differentiate it? Okay, instead of expanding it. Okay, so dy dx, it will be given by u, keep it unchanged, multiplied by differentiation of v, plus v, keep it unchanged, then differentiate u, so du dx. Okay, the short form for this will be y prime equals to uv prime plus vu prime. So you still remember what is prime? Y prime means the differentiation of y. Okay, so this v prime means differentiation of v, this u prime means differentiation of u. Okay, I think that's okay for you. So for quotient rule, you have something divided by something. Okay, then dy dx will be equals to the bottom one differentiate the top one. I mean multiplication by the differentiation of the top one. Then minus the top one multiplied by differentiation of the bottom one. Okay, then divided by v squared, the bottom square. Okay, and then you can have a short form here also. Y equals to vu prime minus uv prime divided by v squared. Remember the bottom is v squared, not v prime squared. Okay, that's very different. And the difference between these two, you can see that if you interchange these two, it's okay because the middle sign is a positive. Okay, if you interchange these two, it's not okay because the middle sign will be minus. This is minus, so you can't interchange. If you interchange, then your answer will be differed by a negative sign. Okay? Take a few seconds to remember these two formulas, then we'll move on to talk about an example. Alright. So, you are given two questions here, and definitely the first one, you'll be giving these two as u and v, and use product rule. And these two, definitely this u and v, and you are doing quotient rule. If you can try yourself, and the answer is given here. Okay? Try to simplify them and get this answer over here. Okay? If not, I'll just start on this one, the first example. Okay, so first, this one, y is given already, so we want to find dy dx. And dy dx is equals to uv prime plus vu prime. So u, leave it unchanged, 3 minus x squared. Then differentiate this, you'll get 3x squared minus 1. Okay? Then I have to plus vu prime, so it's x cubed minus x plus 1. Then differentiate this, so which gives me negative 2x. Okay? Right, then I have to do what? I have to expand because I need to simplify it. So expand it gives me 9x squared minus 3 minus 3x4, then minus plus x squared. Then the other one here, it will be minus 2x power 4, then plus 2x squared, and minus 2x. Alright, so I'm given this long bunch of things here. So how do I actually start collecting the terms? So I start from the highest power. Okay, I look at the highest power here. The highest power here is 4. So I look at 4, okay, x to the power 4, x to the power 4. Minus 3, minus 2, so I should get minus 5, x to the power 4. Okay, then I get minus 5, x to the power 4. Okay, then I'm done. Okay, if you have a pencil, you can cross this out, Okay, so next, what do I need to do? 4, then next one is power 3. Since there is no power of 3, so I move on to x to the power 2. X to the power 2, 9 plus 1, 10 plus 2 is 12. So 12x squared. So plus 12x squared. All right, the next is what? There's only power of x and constant, so power of x, not only this one, minus 2x. So minus 2x, and then last one, only constant term, minus 3. So minus 3 is here. So I've been checking the answers, so it's consistent and it's correct. All right, so you get this answer. Okay, it's not very difficult to actually join them together or merge it together, collect them and simplify them. It's a matter of patience. Okay, you do it carefully and write the terms nicely. Okay, all right. So move on to the next one. U is this one, V is this one. So here I will write it here maybe. dy dx is equals to vu prime 3x minus 2. Then differentiate u, it gives me 2 minus top differentiate bottom 2x plus 5. Then differentiate bottom, it gives me 3. Then divided by 3x minus 2, the whole thing square. Okay, then you expand it. By expand it, it doesn't mean that you expand this one, okay? Okay, it doesn't mean that you expand this one. You expand this one and simplify the top one, okay? And see the top one, whether there's a factor to be cancelled off with the bottom one, okay? Right, so let's move on. Next one, I multiply it in, so I get 6x minus 4. Then minus, okay, so I think I can multiply them, everything here, plus, so everything in here will be minus, correct? So 6x, so minus 6x. Then 5 times 3 is 15, so it's minus 15 because of the negative here. All right, then divided by 3x minus 2, the whole thing squared. All right, so 6x and 6x, coincidentally, they cancel off. They cancel off. So 94, negative 15, so again, negative 19 divided by 3x minus 2, the whole thing squared. Then that's my answer, and it tallies with my given answers over here. Right? You're good? You're good. Then let's move on to the next one. Okay, so can I or shall I use product or quotient rule on these two? Okay, why do I ask this question? Okay, a lot of you will think that, oh, this one is a function multiplied by another one, like something multiplied by something, so I should use product rule. And this one is something divided by something, so I should use quotient rule. The thing is, can I? Yes, you can. You can use product rule and quotient rule. But shall I use? No, you shouldn't. Okay, you can and you should not. Okay, you should not use, because it has an easier way, right? Okay, how is it easy? Let's say I want to differentiate this. The differentiation will be just dy dx is equals to a constant multiplied by a function. So it's equals to constant, put it outside, and differentiate the function. So this one is just 3 times 2x. And I'm done. How about this one? This one is actually what? Something divided by a number. This is a number, right? This is a number. So this number, I can bring it out, right? So it's dy dx is equal to 1 over 10. And I just differentiate this. So it's 10x minus 6. Then I get my answer. So that's so simple. Why do you need to use product and quotient rule? Okay, so let's see. You insist to use, what will happen? Okay, this is u, this is v. So I have this one, right? uv prime plus vu prime. Okay, vu prime. Your u, differentiate it, differentiate 3, you get 0 because it's a constant. Okay, so this is du dx, that's dv dx. And hence, we get the answer, 3 times 2x, which is 6x. So do so much just to get the answer, I do it in one line. Okay, another one. Let's say this is u, this is v, then I do it. So vu prime, okay, you get this, minus uv prime, you get 0. Okay, then I get this thing, which is the same as what I do here. Okay, 1 over 10, 10x minus 6. I didn't simplify it because I want you to see the answer. Okay, so you only use product or quotient rule when the two things are having x inside. Okay, let's see here. This is 3. There's no x there, right? Okay, so you don't use product rule. Okay, you can use, but like it takes a longer time. Okay, so if both have x, then you use it. All right. Okay. So find dy dx and simplify this. So easy. Let you pause the video and try this. Answers is given here. Okay. All right. Okay. So this will be the answers. Okay. I've shown you here already. So dy dx is u v prime plus v u prime. Okay. U v prime plus v u prime. Sorry. Then you multiply them, expand them, and collect the terms with the highest power first, then slowly decrease. Okay. Get this answer, which tally with this. Okay. Next. Okay. This one. Okay. You are still going to use product rule, and d dx 1 over x, you have to remember, is d dx of x to the power -1. Okay, I'm referring to this term. Okay, this term 1 over x. How do you differentiate this? Is you write this as x to the power -1, then it's negative x negative 2. Okay, then let's do it. Okay, you have this one u v prime, v prime here. You see, differentiate 3 is 0. Differentiate this one, you get negative x negative 2. But the negative and the negative will be cancelled off. That's why you have a positive. Okay, then you have this v u prime. So you have 2x here. Okay, then it's expand them. Expand them, you know how to expand? Like for example, this is x squared, x to the power -2. They have the same base. So you multiply them, the power will be added. Okay, added means 2 plus -2, which gives you 0. X to the power 0, which gives you 1. Okay, 1, this one. Okay, it gives you 1, which is 0. Sorry, it gives you 1, the power is 0. Okay, then next, you multiply these two, you get this one, and then you combine them, you get this one, which is the same answer as that one. Okay, you just have to write this one as 1 over x squared. If you can, I really want you to remember this one. Differentiate 1 over x is negative x negative 2. If you can, and write really fast. Okay, two things you should remember. One is differentiation of 1 over x is negative 1 over x squared. And in this form, if you can remember. Okay. Second thing is differentiation of square root x is 1 over 2 square root x. Okay, how do I get so fast? Because I've done this a lot of times, but then I hope you can remember this. Okay, what is this? X to the power 1 over 2. How do you differentiate x to the power 1 over 2? So this will give you 1 over 2, then x to the power -1 over 2. So what is this? This is exactly this one, 1 over 2. Then x to the power -1 over 2 is 1 over x squared x. So this is this one, same thing. So if you can remember these two, then that will be good. Okay, because it always come out in your exam or somehow. Okay, next. You have quotient rule over here, and pause the video and try it. Answer is given here, and let's move on to try this. Okay. All right. Okay. So now this question over here is nothing special, but again the square root, like I said, it always comes out. So I have shown you differentiation of square root x is 1 over 2 square root x. Okay. So this one again, if you are doing it first time, you will be writing x to the power half plus 1, x to the power half minus 1. Then you differentiate this one, is the thing that I worked out just now already, is 1 over 2 square root x. Hence, this differentiation will be v u prime minus u v prime. Okay, I let the top to be u, let the bottom to be v. V u prime minus u v prime divided by v squared. I want to keep it clean. I want to make it nicer to look at. So instead of writing x to the power 1 over 2, I write square root of x and so on. Okay, and it's easier for you to cancel. Okay, then you multiply them together. Multiply them by doing what? You see, this one and this one are the same. So I bring them out, and inside I just write this. Okay, this is something common factor k. So k I bring it out. This is a minus b. A minus b. Okay, the factorization. I hope you are doing fine with this. Okay, then what's next? You see, square root x and square root x can be cancelled off. minus 1, minus 1. So minus 2 here. Minus 2 and minus 2 can be cancelled off. Hence, my answer will be minus 1, it's left on top. The square root x, instead of writing on top, I write below. So it's square root x here. Okay? Alright? Alright. I guess you are doing well. Okay, next one. Okay? Here, u, v. Then, again, this one, to remind you, differentiation of square root x is 1 or 2 square root x. Okay? Then, differentiation, again, this is u, this is v. So, I am doing v u prime minus u v prime divided by v squared. Okay, then no problem except this one. You might need some time to get used to it. Next, okay, this is the simplification here. 5x over square root x. What is this? You see, x over square root x is equal to what? X over square root x, because x is what? Square root x, the whole thing square. So square root x actually can cancel with x. That gives you square root x only. Okay, I'm referring to this one multiplied by this one. Okay, so this is this thing. Okay, hence the next line you get things like this. Okay, this one you get negative 5 square root x because the square root x and the x will be cancelled off. Then it's left with square root x on top. Okay, then it's left with square root x on top, and then we get the bottom here. This is something ab squared. It's a squared b squared multiplied together. A squared is 4, b squared is x. Okay, so it's 4x. All right, then I get my final answer here, which I have to simplify. Do I have to? I guess I don't have to. So this is the final answer. Okay, it's the same as this one. Okay, except I read the 1 over 4x outside. All right, you good? You good? Yeah. Okay. So let's move on. Okay, so let y equals to 2kx squared. So you have k now. It looks like SPM question now, right? Okay, 2kx squared minus 4x minus 7, where k is a constant. Given that when x equals to 2, dy dx is equal to 12, find k. So what you do now is to differentiate. Okay, differentiate this one. Okay, dy dx is equal to 4kx minus 4. Okay, no problem, right? So k is a constant, so you treat it as a constant. Differentiate a constant times x. The constant will bring it out, then differentiate inside. Constant bring it out, you get 2k. Then differentiate x squared, you get 2x. So you get 4kx. Okay, this one differentiate no problem, negative 4. Okay, and it says that dy dx will get 12 when x is equal to 2. So when you substitute 2 into here, you should get 12. Okay, then substitute 2 into here. Okay, then I get 8k, not 8x. Okay, because you substitute x equal to 2, not k equal to 2. You do not know k. Okay, so 8k minus 4 is equal to 12. So now this 12 comes from where? Comes from the question here, because you know x equal to 2, dy dx is equal to 12. Okay, then now you get an equation of the k. K, you can find it now. All right, so 8k is equal to 16, k is equal to 2. So easy. Okay, no problem, right? No problem. Great. Okay, if you have any problem, just pause the video and look at the steps. Okay, right. Next, here, fx is given by, again, something in terms of k, right? Okay, x cubed 2k x. Find k if f prime 1 is. So pause the video and try this. Answer is given here. It's 3. Okay, if you have done it, then I move on to talk about the answers. Okay, I'll do this question. F prime of x. Okay, again, you see, when you have y equals some function of fx, function of x, then you write dy dx. If it's given in terms of fx, you don't write dfx dx. Okay, you write f prime. F prime means the same thing. It means differentiation or the derivative of f. Okay, it's a notation here. So f prime x will be equal to 3x squared. Then this one is a constant. Constant I write in front. Differentiate this x squared, I get 2x. So plus 4kx. Okay. So f prime I substitute 1, I'll get 15. So 15 is equals to f prime of 1 is equals to 1 is here. 1 substitute here, what do you get? 3 plus 4k, because 1 is here. Okay? 1 you substitute into 1 and x here. Okay? So you get 4k. Alright? So then I solve for this. 15 is equal to 3 plus 4k. So 4k is equals to 12. So k is equals to 3. I am done. Very simple. No problem with this? Alright, great. So let's move on to the next one. Okay, now it's homework time. So I'll leave this for you. So find the derivative for this and answer is given in the next slide. So copy down the question. Okay, then I'll show you the answers there later. Then you just check it or just copy down as well. Okay? Okay, answers here. Okay, if there's any problem, just tell us. Okay? Alright, if there's nothing, then I'll see you in the next lesson.